Okay. All right, so today we're going to be doing Unit 5, Systems of Inequalities. Lesson 3, which is Solutions to Systems of Equations through Forced Elimination. So the idea of forced elimination is basically where you have to solve systems of linear equations, and you have a system where you have coefficients in front of the variables, and you need to multiply both or one of the equations by some number, so that way you can eliminate a variable so that you can solve it. So, forced elimination method consists of, if there are no coefficients, no common coefficients, multiply one or both equations by a number to force the equations to have matching or opposite coefficients. Okay? So when you want to eliminate two variables, you need to make sure they have the same coefficient but opposite signs. So like 2x and negative 2x, 4x and negative 4x, 3y and negative 3y, negative y and y. Those are opposite, the same coefficient, opposite signs. That's what you want in order to eliminate them. Because if you add opposite signs together, same coefficient, they're going to go away. So that's going to be our goal for the lesson. So now we're going to start with number 1. So on question number 1, you'll notice that there are no common coefficients here. You see how the x has a 1 in front of it, this y has a 3, this one has a 2, and this one has a 7. So we're trying to think, what can I multiply this equation by to get rid of the x's, say? So if I make this coefficient what would the x's cancel out? How could I get the x's to cancel out?
0.
Not 0. Well, we want to make it 0, but what can I add to 2 that would make it 0?
Negative 2.
Negative 2. Good, negative 2. So we need to take this first equation, and we're going to multiply the whole thing by negative 2. Okay? And that's because we want the 2's, the 2x's to go away. And the only way we can do that is if we have the same number but different sign. So here we have a positive 2x. We want to make this a negative 2x to make it go away. So what I'm going to do here is I'm going to use the distributive property and multiply all three of those terms by the negative 2. That's going to come out to be negative 2x minus 6y is equal to negative 12. So that is the result of my multiplication. Now you're going to take the bottom equation and you're going to rewrite it so that it sits directly underneath the one we just did. Just like this. And what's going to happen to these x's now? Cancel out, which was our goal. Negative 6 minus 7 is negative 13y. And then negative 12 minus 1 is also negative 13. And what would be my last step to solve for y? Divide both sides by? Negative 13. Anything divided by itself is what?
0.
Not 0, but 1. So we found y, but we're not done because we have to go back and find what?
Oh my God.
X. So we're going to go back and find x. So I'm going to take this equation right here. And I'm going to plug in for y. That's going to give me x plus 3 is equal to 6. And then how would I solve for x here? What's x going to be here? X plus 3 equals 6. What does x have to be? One-step equation, guys. What plus 3 is equal to 6? 3. There we go. Okay. So, how you write your answer? Always, and this will be what you have to do on the test. X, comma, y, parentheses. So your x always goes first. So the answer to this is 3, comma 1. That's the final answer. Does that make sense to everybody here? Anybody have any questions? All right, let's move on to the bottom one here, number 2. Well, bottom for me, middle for you guys. So, On this question, once again, I don't have any of the same variables going on here. See that? They're not the same numbers. So I'm going to have to multiply the bottom equation by something. Now the easiest thing to always use is the one that doesn't have a coefficient at all because it's like a blank slate, right? So if I want to cancel out the 3y, I'm going to need a negative 3y, right? So if I multiply this whole bottom equation by negative 3, I can make that coefficient of the y negative 3, which is what I want, right? So I'm going to take that bottom equation and I'm going to multiply it by negative 3 because that's going to make the y's cancel out. I'm going to use the distributive property here. And when I do that, I get negative 6x minus 3y is equal to negative 15. Once I have that, I'm going to write the first equation underneath it to line it up. Because you always want to line up your like terms. And then I'm going to add them together. So what's 9 minus 6? Good, 3x. What happens to the y's? Cancels out. Equal to negative 15 plus 12.
Or negative 13.
Not negative 13, but negative 3. If it was 2, yes, so negative 3. Then we divide by 3, and we get x equals negative 1. So, you're going to pick one of the original equations. I picked the easier one because I don't want to make my life any harder than it has to be, right? And I'm going to plug in for the variable that I know to find the variable I don't know. What's 2 times negative 1?
Negative 2.
Thank you. Negative 2 plus y is equal to 5. Then I'm going to do what with the 2? If it's negative, I reverse the negative. Good, add. Add 2 to both sides. That's going to give me y equals 7. Okay? Now I have x and I have y, which is what I want. You always write it x and then y. Just like the alphabet, x comes before y, same thing with math. X comes before y in the ordered pair. So far, does it make sense? Yeah? All right, we got 2 more note questions, and then you guys will have negative 2 is negative 4. There we go. Now we're going to add these up. What's 6x minus 6x? Good, 0. What's oh, that's a positive. That's why. There we go. Sorry. What's 2y minus 2y? 0. And then what's 4 minus 4?
0.
So what do you notice at the end? Are any variables left?
No.
Does anybody know what it means when we get a true statement? Not no solutions, but true statement means we have
No solution.
not no, but infinite. Good, infinite. Infinitely many. So what that basically means is these 2 lines just overlap each other. On the graph, they just go right on top of each other, which means they share all the same solutions. Infinitely many solutions. So if you get a true statement at the end, and I will ask about this on the quiz, you get a true statement at the end, you know that it has to be infinitely many. If you get a false statement, that's where you have no solutions, okay? Everybody ready for 4?
No.
No? Okay. Sure. So in this question, we have to multiply both equations by something. So, not divide, but you could, but I don't know if it's going to help us too much here. Oh, yeah, that would work. Okay. I see what you're saying. So, yeah, you could. You could divide this whole second equation by what?
2.
2. Yeah, that would work. But even better, we could divide it by Not 2, but 3. 3 would work, right? And if we divided it by 3, we can see what happens here. I don't think it's going to help us too much, though. Yeah, we can do that. Okay, let's divide the whole thing by 3. There's several options on this one, so. We're going to divide everything by 3. And when we do that, we get x plus 2y is equal to 4. So now that we have that, what could I then multiply this equation by to get it to cancel out with the first one? Not 2, but negative 2. So we're going to multiply this equation by negative 2. Distribute. You get negative 2x minus 4y is equal to negative 8. And then remind me, what's my next step here? Not subtract, but combine like terms. You got to line them up. So line them up, just like that. Take the first equation, line it up so that you had all the like terms are lined up. And then we're going to add them together. So what happens to the x's here? What about the y's?
They also cancel out.
Good. And then what's negative 8 plus 6?
Negative 2.
Negative 2. Is this a true or a false statement? False statement. Which means we have how many solutions? No solutions. Anybody know, for a bonus point, what these two lines look like on the graph?
One's vertical.
There's a word for it.
Parallel.
What's the word we call these two lines that sit?
Parallel.
Parallel. All right.
I stole the bonus points.
You what?
I stole the bonus points.
I mean, they're there.